Our next subject is maximum and minimum values of functions. So you kind of know already what this is, right? The maximum value is the biggest value and the minimum value is the smallest value. For sure, that's exactly what it is. But we do actually have two types of maxima and minima that we're going to talk about. So it's important to understand the distinction between those two. So that's what this lecture focuses on. So let us define, we're going to take a function, f of x, and it's on some domain D. And we're considering the point C as one of the points in D, right? So then what we want to define is the absolute maximum and the absolute minimum of that function on D. So obviously it's going to be the absolute maximum is going to be the biggest value f takes on the domain, and the absolute minimum is the smallest value that the function takes on the domain. Fine. The important thing about that is that the definition of absolute max and absolute min includes the domain that you're talking about. So if the domain of your function changes, your absolute max and your absolute min will change. Okay? And we'll see in a minute, we'll look at this with some pictures. However, one of the things we already know about is that a lot of our functions, let's say something pretty wiggly, we might be interested in where is it wiggly, and here's a bunch of points, right, which are not the absolute max or the absolute min, but they're still essentially like the top and bottom of a curve, like a hump or a valley. And those are interesting points too. We already know those points are interesting because they have a horizontal tangent, for example. We've been talking about that, right? So although it's not the absolute maximum over the whole thing, it's still interesting. Locally, it's still a maximum. So, or in this case, a minimum. I said maximum, I circled the minimum, but either way, maximum or minimum. So that's why we have also defined local maximum and local minimum. So the way these are defined, this is in your book, it says a local maximum of f. F of c is a local maximum of f if, what did I do? Put these things in the wrong place is what I did. Swapped my x and my c, that's no good. There we go. Fixed it. Okay, so if the value, of course, is bigger than anywhere around it, right? So for x near c, and it's a minimum if it's at the bottom, if f of c is less than f of x for x near c. All right, so x near c, like what does that actually mean? That's important. What it means is near c in this case means in an open interval around C. It can be a very small open interval, but it has to be an open interval around. So let me write that here. It actually means, and what's important about that is that we really want to see this behavior where the point is either the top or the bottom, not just like at the endpoints. So I wouldn't call this a local min. I wouldn't call that a local max because they're at the endpoints. But certainly for this function, this is the absolute min because that's the lowest that the function gets. So let me give you a better example than just this little crappy thing I drew on the board. Okay, so here's a function. Away there. So here's a function, x cubed minus 12x plus 4, right? So this would be kind of a pain to draw by hand, right? You had to plot a bunch of points, right? Because it's not something simple like a parabola. And it's also not easy to solve for where the roots are, right? If I look at where these cross the axis, it's some weird thing, right? It's not a nice answer. It's not a nice number, right? But if I look at this, I can see certainly this top point here And this bottom point here, I've got one local maximum and I've got one local minimum. Now, what about the absolute max and the absolute min? Well, this function here, as you see, I just put it for all r. And what's happening with this function, of course it's a cubic, is going off to plus or minus infinity. So this function, the way it is, it doesn't have any absolute max or absolute min because it's going off to plus infinity and minus infinity. There's no maximum value that's going to work for all of the x in R. But what I can do is I can actually make my domain a little smaller, right? So here I've taken the domain from 0 to 3 instead. Let's break that guy up. Now I have this function on this restricted domain, which is a closed interval, by the way, right? So I can see the biggest it gets is going to be here at 0. So my maximum value is 4. And the smallest it gets is this point in the middle. So my minimum value is negative 12. Or I could make it different. Oh, here's some very boring part, right? Here, I don't have any of the peaks or valleys. I don't have any of the local mins, but certainly I have a maximum value that the function has. And on that interval, does this look as looks, it's negative 13. And at the bottom of the interval is negative 12. So when we're talking about absolute maxes and mins, they can appear on the inside of the interval. They can appear on the endpoints as well, right? It's just going to be the biggest value that it is and then the smallest value that it is. Okay. But you don't have to have an absolute max or min, and you may not even necessarily have a local max or min either. If I took just a regular old line, right? If I do y equals 3x, this is a perfectly legitimate function, but it has no maximum or minimum of any kind, right? Because it's always increasing. Or if I want something that's not as boring as a line, well, let's do y equals e to the x, minus x. Let's do minus x, okay? Why? Why do I want to do minus x? I don't know. I'm in the mood for minus x. All right, so here we have this guy. Also interesting because it has no maximum, it has no minimum because it is always decreasing, right? And it does, you would think, and this is an important point, you would think, oh, well, I can see maybe the minimum 0 because it's going down to 0. Well, it's approaching 0, but the important thing about maximum and minimum is if you look at the way it's defined, the function has to have a value, right? F of c has to be an actual number, right? So for this e to the minus x, you're never going to actually ever get down to 0, right? You're just going to get arbitrarily close. So that's another important thing that we need, that we'll talk about, that we're talking about now. The maximum and the minimum has to be realized. You have to get there. Okay, otherwise it's not a maximum or a minimum, it's just a bound. So the maximum and the minimum of the function has to be a value of the function at some point, right? Here's another example. I have another one here, which is maybe a little bit more interesting because it has more wiggles. It's the same kind of thing, right? This is to point out you can have more than one local max or local min, right? So here it looks like I've got two local maxes, these two, and I just made this function up so that it looked cute, and there's two local mins right there. So if this isn't going to work out well, that's why all these numbers are decimals, because I just plugged in some numbers here so that I had something to look at. So this function, we have two local maxes, two local mins, and we have no absolute max or no absolute min because, again, we have given it a domain, it's going to assume the domain is all of R. One thing I want to make sure of, okay, so the absolute maxes then are this 12.125 and this 1.3929, and the absolute min is, I'm sorry, absolute, I meant, I don't want to do this whole thing again. Local, so these are local maxes and local mins. So the local min here is 0.872 and this local min is 0.253. So when we're talking about the value of the max and the min, it's the y value. And we say it happens at the point, whatever the x value is. All right, so now let's put some restriction on so we can also talk about absolute max and min. So here my restriction, which it's, oh, well, how about this one? Yay! All right, here's a different one. I mean, here's my restriction was -2 to 2. I can see that. The other one I think went to 2.5 or something because I wanted to get, but anyway, so here's -2 to 2. So, but what's interesting here is that our absolute max is clearly this endpoint here, right? So that's going to be 15. Our absolute min is this little guy who's also a local min. And then we have some other local mins and maxes inside my interval of interest. And of course, I can always like switch it around. Like this one was the other guy, was similar to the other guy where even though this function has a lot of stuff going on, right? It had a lot of wiggles, but on the interval that I chose here, which I think was -0.5 to -3/2, yeah, it doesn't have much going on. So this is going to be the maximum, and this is going to be the minimum. Absolute max, absolute min, no local maxes, no local mins. Okay. And one last thing I wanted to point out is, again, even though if you have an absolute max or an absolute min, it can happen at the endpoint, it can happen inside, but for a closed interval like this, you're just going to have one that's the absolute max and one that's the absolute min. If you have an open interval or the whole real line, you may not have any, okay? But local, because it has to be real, all right. Never mind the way I said that. You may not have any. It has to be, but when it has, let's see, let me do this. Let me stop share. All right, so let's look at the definition. It says f of c is greater than or equal to f of x for all x in D, okay? So because it's for all x, there's only going to be one value at most that's going to work, right? And the same thing for the absolute min. Now, it might happen at many points, right? So c might not be unique, but the value of f of c, there has to be at most one. For example, if we look at, say, the sine function here, actually, I think I put sine of 2x, or 2 sine x, fine, whatever. So this is 2 times the sine function. We can see the absolute maximum is going to be 2, and the absolute minimum is going to be -2. But we know there's a whole lot of different points where that happens. But of course, it's never going to get bigger than 2 or smaller than -2. So that's the absolute max and the absolute min. In this case, those are also local maxes and mins because I took it all over. So in this, here's an example where you have an infinite number of points where the maximum happens, and you have an infinite number of points where the minimum happens.